Okay, for number 2, I just want to remind you that it's geometric in form, so I'll write this over here. 1 minus u, 1 over 1 minus u equals 1 plus u squared. And you probably should, really have this, covered at this point. And this goes on forever, provided that u, or the absolute value of u, is less than 1. All right? So when I see this over here, what I would do is, write down, so it looks sort of like that. So 1 minus, that would be minus 8x. And let's go for it. What do you get over here? Well, let's see. 1 plus minus 8x plus minus 8x squared plus minus 8x cubed plus yada, yada, yada. With the understanding that minus 8x, the absolute value of it, is less than 1. Let me just go through that with you. 8, absolute value of x, 1. The absolute value of x less than 1/8, which means x is between 1/8 and minus 1/8. All right? I'm going to realize it's a sum problem, and you don't have to, but I think it's a good idea to do that. It's much more compact. And I'm going to say n equals 0 to infinity and minus 8x to the nth power, right? That's a possible answer. Let me write another one down for you. N equals 0 to infinity minus 8 to the n, x to the n. You could write that one down. You could also factor out minus 1 and write it a little differently than that. But let's take a look at the k. And when I do that, I want to make sure I'm looking at what I expect to look at, which is an answer. Right? I'm expecting an answer like this. That's what I'm expecting. I see that here. And I'm also expecting to see an answer like this. And I see that right over here. What else do you expect to see? Something related to its the place where it's going to be valid. And that's when the absolute value of x less than or equal to 1/8. I'm sorry, less than 1/8. I like to write it this way over here, but again, you don't have to. I want to just say that's one way to do it, and I'm going to say it's probably the best way of doing it. Now, of course, opinions really don't matter much. It's your opinion, but there are other ways to do it, and I want to point this out to you that it's more involved. But we'll get the same answer. So let me point out what that other way is. It's just taking derivatives. So f of x is 1 over 1 plus 8x. So I'm just going to say 1 plus 8x to the minus 1. Now, the worst part about this is it requires taking derivative after derivative, hopefully to see a pattern here. And what do you get there? Minus 1 plus 8x to the minus 2 times 8. All right, let me keep going. F double prime. And again, I'm hoping to see a pattern here. What do you get there? Well, you get 2. The root of that minus 2 times minus 1 is 2. Then you get 1 plus 8x to the minus 3. Inside is another 8, so it's 8 squared. F triple prime. What do you see here? I see a minus. Now I see 3 times 2, which is 6. 1 plus 8x to the minus 4. And then derivative inside is 8, so another 8 there, so it's 8 cubed. So I'm kind of seeing a pattern, and you could just say, blah, blah, blah. But I want to point out, I could probably just write down the next derivative without, taking it, just by looking at the pattern. And I'm going to say f4, that's the fourth derivative, in parentheses, of x. Well, I know the sign of it, it's going to be positive. All right? I'm looking at these numbers in the beginning, 1, 2, and 6, and I recognize them as factorial. 1 factorial, 2 factorial, 3 factorial, 4 factorial. Now, I'll write that down. And then I'm going to get this 1 plus 8x. And I'm going to say minus, well, look at it. It's really going to be 1 more than the number of derivatives, so minus 5. And then I get 8 to what power? Well, it's going to be 4 now. All right? So I think I recognize that I can write down the nth derivative now. Well, it has something to do with minus 1 to a raised to a power, that's for sure. Now, it seems like the odd powers are giving me negative numbers, and even powers are giving me positive numbers. So I'm going to say n. All right? So like a first derivative give me minus, second derivative give me positive, third derivative, and this depends on the derivative, by the way, What else do I see? I definitely see a factorial in the problem. What's the factorial? N factorial. What else do I see? 1 plus 8x. And it's related to n, and it's really 1 less than that. So it's going to be minus n minus 1. All right? Then what do you get over there? You get 8. There's a number of factors over there. And how many are there? Let's take a look at it. It looks like there's going to be n of them. I'm going to pull this together a tiny little bit because then it is this one and this one can be pulled together. And what would you get over there? You get minus 8 to the nth power, n factorial, and then 1 plus 8x raised to the minus n minus 1. All right? So what do I do now? I didn't even say I forgot what you're doing. I'm trying to get a Taylor polynomial centered at 0. Let's go back up here. So find the Maclaurin series corresponding. Maclaurin's centered at 0, by the way. Interval convergence, yada, yada, yada. We just did it, but we're going to get the same answer, of course. Let's take a look at it. And the way to do that is to start to evaluate these functions at 0. So what's f of 0? And it should be easy to do, by the way. That's going to be what? F of 0 is just going to be 1. Let's write down f prime as 0. And again, we're looking at these things over here. That looks like minus 8 to me. F double prime of 0. Again, I'm looking at it, and what do I notice over there? I notice there's a 2 and an 8 squared. I'll put this down. Now, by writing things down, you might see a pattern. And what do you get there? You definitely get negative. And I notice a 6. I'm going to write it as a factorial, by the way. And then what do you get? You get 8 cubed. I'm going to write these, they all look the same to me. F of 0. Certainly note there's a 1 there. Let me go backwards. Might be a little easier there. F triple prime minus 3 factorial times 8 cubed. F double prime. I'm going to say 2 factorial times 8 squared. Again, I'm going backwards. I'm just looking at this. F prime a 0. I'm going to say, let's see, 3 factorial, 2 factorial. Let's do the sign first. That's going to be minus 1 factorial. And then you're going to get 8 to the first power. All right? Let's go backwards 1. What would that give you? 0 factorial, and then 8 to the 0. All right? 8, 8, 0, 8, 1, 8, 2, 8, 3, so forth and so on. And I think I see the pattern right away. So, you could write down the polynomial now, and it's really not bad to do. You can write it as a sum. And what's this problem over here? Oh, let's write it down. F of x is equal to, on some interval, I'm going to put n equals 0 to infinity. I'm going to put the sign of it down, and the sign would be, let's see, 0 gives you positive, so I'm going to say minus 1 to the n. I see there's a factorial. I'm going to put n factorial down. And then I see an 8. And what's that going to be? 8 to the n. All right, then what I put over here, x to the n now. Let me simplify a tiny little bit. N equals 0 to infinity minus 8 to the n factorial. Oh, I forgot to do something. I just noticed it. Someone says, why'd you just notice it? It's really not making much sense over here. You're dividing by n factorial. All right, so that's gone. Sorry about that. And then you get x to the n. That's the problem with doing things that are sort of long-winded. You forget things as you're going through the long-winded conversation. All right. What do I know about this guy over here? Looking at you can do the ratio and root test on it, but I think for the most part these are coming somewhat obvious to you that the absolute value of x is going to be less than 1/8, or for that to be convergent. So let's go back over the notes and see if we got that answer. And we got that answer. All right. We also talked about using the the interval convergence, minus 1/8 to 8th, right? We did that before too, by the way. Again, let me point this out again. I believe the best way of doing it is recognizing that this was geometric in form and going that direction. I don't think taking derivatives is a great idea. It requires seeing patterns, evaluating, and it can get really nasty if the derivatives are hard to do. Thank you.